بسم الله الرحمن الرحيم والصلاة والسلام على أشرف المرسلين سيدنا محمد وعلى آله وصحبه أجمعين. السلام عليكم ورحمة الله وبركاته. This video will be about the Cartesian product. This video is prepared and presented for you by Mr. Ahmed Al-Wais. By the end of this video, you will be able to explain what the order pair is and give examples of its uses. Apply the equality of two ordered pairs. Define the Cartesian product of two sets. Find the Cartesian product of two finite sets. Find the number of elements of the Cartesian product of two finite sets. And finally, express the Cartesian product in its different forms, which are set of ordered pairs, arrow diagram, and Cartesian diagram. Let's start with ordered pair. Ordered pair is an expression that's used when order matters. The form of the ordered pair is A, B. You can note that this form is about two parentheses or round brackets. They contain two projections, A, the first projection, B, the second projection. They are separated by a comma. Of course, the ordered pair is not a set, but it is an element. A and B are not elements because the ordered pair is not a set, so A and B are not elements, but they are projections as we mentioned before. A is the first projection and B is the second projection. In the following, we will see when we should use ordered pair or when we should use a set. In which case we use an ordered pair and in which case we use a set. When you are asked to tell your first name and your last name, what is suitable? To use an ordered pair or to use a set? Of course, to tell your name, you tell your first name and then your last name. Then in this case, order matters, so you have to use an ordered pair. That's the second case, when you are asked to list the names of your two brothers. In this case, order doesn't matter because it doesn't matter which one of your brothers you tell first and which one you tell second. So, since order doesn't matter, so in this case we use a set. The most two fruits you prefer, when you are asked to tell two fruits you like most or you prefer most, it doesn't matter which fruit first and which fruit second, so order doesn't matter here. So in this case we use a set. Finally, the order of the two top teams in the Egyptian soccer league. Of course, order here does matter because the first should be first and the second should be second. That's why we have to use an ordered pair in this case. Choose the correct answer. A space A, B. Belongs, doesn't belong, subset, or none of these. We already told or mentioned that the ordered pair is not a set and A is not an element. The ordered pair is an element and A is a projection. Belongs, doesn't belong are used to express the relation between an element and a set. So they are not suitable to be used here in this case. Neither subset, because subset is to describe the relation between a set and another set. So the right answer is none of these. Order pair 2, -5 intersection order pair -5, 3 equals set of -5, -5, 5, or none of these. Intersection is an operation on sets, but you know that the order pair is not a set, so we cannot use this operation on order pair. So the right answer is none of these. Now we are going to know when two or more ordered pairs are equal. If the ordered pair A, B equals the ordered pair X, Y, that means that A equals X, the first projection of the first order pair, equals the first projection of the second order pair, and B equals Y, the second projection of the first order pair, equals the second projection of the second order pair, and vice versa. Meaning that if A equals X and B equals Y, so the order pair A, B equals the order pair X, Y. For example, if the order pair A, B equals -5, 9, that means that A equals -5, the first projection equals the first projection, and B equals 9, the second projection equals the second projection. Okay, another example. If A, 3 equals -1, B, it means that A equals -1, the first equals the first, and B equals 3, the second equals the second. As an application on the equality of two ordered pairs, let's solve these problems. Find the values of A and B in each of the following. If A, B equals -5, 9, pretty clear. A equals -5, first equals first, and B equals 9, second equals second. Number 2, A minus 2, B plus 1 equals 2, -3. A minus 2 equals, exactly, equals 2. First equals first. That means that A equals 4. And B plus 1 equals -3, second equals second, and that means that B equals -4. So A equals 4 and B equals -4. Number 3, 6, B minus 3 equals 2 minus A, 2B minus 3. That means that 2 minus A equals 6. So A equals 2 minus 6. A equals -4. And B minus 3 equals 2B minus 3. Then 2B equals B. Then B equals 0. Choose the correct answer from those given. If X minus 1, 11 equals 8, Y plus 3, then root of X plus 2Y equals. To find the value of root of X plus 2Y, we need to know the value of X and the value of Y. From the equality of the two ordered pairs, we can say that X minus 1 equals 8. That means that X equals 8 plus 1, 8 equals 9. Now, from the equality of the two ordered pairs, Y plus 3 equals 11. That means that Y equals 8. Since Y equals 8, so 2Y equals 2 times 8 equals 16. Then X plus 2Y equals 9 plus 16 equals 25. Then the value of root of x plus 2y equals root of 25, which is 5 or positive or negative 5 or 25 or root 17. Some of you may say that it's B, positive or negative 5, but it's not the right answer. The right answer is A, because this sign is the sign of the positive square root. So the answer is 5. If x plus 2 comma y equals 2 comma 3, then x to the fifth times y plus 1 equals, from the equality of the two ordered pairs, x plus 2 equals 2, so x equals 0, so x to the power of 5 or x to the fifth equals 0, so x to the fifth times y equals 0, whatever the value of y. So the expression x to the fifth y plus 1 equals exactly 1. Number 3, x squared comma root y equals 1 comma 4, then x plus y equals, again we need to know the value of x and the value of y. From the equality of the two ordered pairs, x squared equals 1, that means that x equals, no, not 1, x equals positive or negative 1. Since x squared equals 1, so x equals positive or negative 1. Okay, so x has two values, positive 1 or negative 1. Okay, from the equality of the two ordered pairs, root y equals 4, that means that y equals 4 squared equals 16. Now we can find the value of x plus 1. Will be this value 2, 17, 15, or B or C? Let's find this value. We said that x equals 1 or negative 1 and y equals 16. So x plus y equals 1 plus 16 equals 17, or negative 1 plus 16 equals 15. So the right answer is D, which is B or C, because x plus y can be 17 or 15. Now let's know what the Cartesian product x cross y is. The Cartesian product x cross y is the set of all ordered pairs whose first projection of each of them belongs to x, and the second projection of each of them belongs to y. X cross y is the set of all ordered pairs whose first projection belongs to x and second projection belongs to y. For example, if x is the set of 1 and 2 and y is the set of 5, 7 and 8, then x cross y equals the set of the ordered pairs 1, 5, 1, 7, 1, 8, 2, 5, 2, 7, 2, 8. You note that the element 1 of the set x has been a first projection for 3 times, each time with one of the elements of the set y. 1, 5, 1 is a first projection with 5. 1, 7, 1 is a first projection with 7. 1, 8, 1 is a first projection with 8. So 1 is a first projection with all the elements of y. The same for the element 2. The element 2 is to be a first projection with each element of the set y. So 2 is the first projection with 5, the first projection with 7, the first projection with 8. So x cross y will be the set of the ordered pairs 1, 5, 1, 7, 1, 8, 2, 5, 2, 7, 2, 8. Example: if x is the set of 1, y is the set of 2 and 3, z is the set of 2, 5 and 6. Represent the sets of x, y and z. Find a x cross y, b y cross z, c x cross z. X cross y. X contains only one element, which is 1. This element will be a first projection with each element of the set y. So x cross y is the set of ordered pairs 1, 2 and 1, 3. Now y cross z, the same. Each element in the set y will be a first projection with each element of the set z, which means that the element 2 will be a first projection with 2, with 5 and with 6, which gives us 3 ordered pairs 2, 2, 2, 5 and 2, 6. The same with the element 3, which will be a first projection with each element of the set z, meaning we will have 3 ordered pairs 3, 2, 3, 5 and 3, 6. Finally, x cross z, the element 1 will be a first projection with each element of the set z, that gives us 3 ordered pairs, which are 1, 2, 1, 5 and 1, 6. I hope now you are able to find the Cartesian product x cross y for any two finite sets. It's very simple. Let's have an exercise. If set x is a set of 2, y a set of 4 and 0, z a set of 4, 5 and -2. Represent the sets of x, y and z. Find x cross y intersection x cross z. Number 8, x cross y intersection x cross z. This is an intersection operation between two sets. What are these two sets? The first set is the Cartesian product x cross y intersection. The second set is the Cartesian product x cross z, meaning that we are supposed to find in the first place x cross y and x cross z. Then we have to find the intersection between x cross y and x cross z. X cross y, which is the set of 2, 4, 2, 0. Intersection x cross z, which is the set of 2, 4, 2, 5 and 2, -2. The intersection here will give us the set of the ordered pair 2, 4. Okay? Number B, x cross y intersection z. This is a Cartesian product of x as the first set and the intersection of y and z as the second set. Okay? The Cartesian product here, its first set is x and its second set is the intersection of y and z. So you have to find the intersection of y and z in the first place, and then find the cross, or find the Cartesian product, x cross y intersection z. So x cross y intersection z equals set of 2, which is the set x, cross set of 4, which is the intersection of y and z. That gives us the set of the order pair 2 and 2, 4. Now you may note that x cross y intersection x cross z equals x cross y intersection z. Tell me, can you prove that x cross y union x cross z equals x cross y union z? Can you prove? Not proof. Okay, can you prove that? Sorry for this mistake. You may note that number of elements of the Cartesian product x cross y, which is denoted as n of x cross y, equals number of elements of set x times number of elements of set y. Okay? N of x cross y equals n of x times n of y. For example, if n of x equals 2, meaning that x has only 2 elements, and n of y equals 3, meaning that set y has only 3 elements. When we find the cross or the Cartesian product x cross y, it will give us 6 ordered pairs. Then n of x cross y equals 6. Okay? Choose the right answer. If n of x equals 3, n of x cross y equals 12, then n of y equals number of elements of x is 3 elements. Number of the Cartesian product x cross y is 12 elements, or 12 ordered pairs. That means that y has 4, 9, 15, or 36 elements. Of course, the right answer is 4. Because we already know that n of x cross y equals n of x times n of y. That means that n of y equals n of x cross y divided by n of x. 12 divided by 3 equals 4. If n of x equals 2, y is the set of 1 and 2, then n of x cross y. Number of elements of x is 2. Number of elements of y is 2. So n of x cross y equals 3, 4, 5, or 6. The right answer is 4, which is 2 times 2. If n of x equals 3, then n of x cross 5 equals 5, 3, 0, none of these. Remember, n of x cross 5 means the number of elements of the Cartesian product x cross 5, which will be 0. Don't be fooled and choose 5. Okay? He is asking here about the number of elements of the Cartesian product, not the Cartesian product. The Cartesian product will give 5, but the number of elements will be 0. Cartesian product on a set x. What does this mean? If X is a non-empty set, then X cross X is the set of all ordered pairs whose first projection belongs to X and second projection belongs to X, meaning both projections of these ordered pairs belong to the set X. It's written in this form, and it's read as x2, not x squared or x to the power of 2. It's read as x2. Okay? For example, if X is the set of 1 and 5, then X cross X or X2 will be, the answer will be as follows. The element 1 will be a first projection with each element of X. So 1 will be first projection with itself, which gives the order pair 1, 1. 1 will be a first projection with the other element, which is 5, that gives the order pair 1, 5. Okay, that's about 5. That's about 1. What about 5? 5 will be a first projection with each element of the elements of the set X. So 5 will be a first projection with 1, which gives the order pair 5, 1. And 5 will be a first projection with itself, which gives the order pair 5, 5. So x2 or x cross x will be set of 1, 1, 1, 5, 5, 1, and 5, 5. Okay? If n of x equals n, meaning that n represent the number of the elements of the set X, then nx2, the number of elements of the Cartesian product x cross x, will be n squared. For example, if n of x equals 3, then n of x2 equals 9, the square of 3. And if n of x2 equals 4, that means that n of x equals 2. Okay? Complete. If x2 is the set of 1, 1, 1, 2, 2, 1, 2, 2, then x equals. Very simple. You can use either the first projections or the second projections to conclude the elements of the set X, because all the first projections and all the second projections are the elements of the set X. So X equals, X is the set of 1 and 2. Okay? If Y cross X is the set of 1, 2, 1, 4, then x2 equals. You may note that X is the second set, or the first set, the second set. That means that the second projections are the elements of X, which are 2 and 4. So X is the set of 2 and 4. Now x2 is the set of 2, 2, 2, 4, 4, 2, and 4, 4. Another example. If n x2 equals 9, then n of x equals, sure, n of x equals root of 9, which is 3. If n of x2 equals 4, n of x cross y equals 6, then n of y2 equals. By knowing that n of x2 equals 4, we can conclude that n of x equals 2. Number of elements of the set X is 2. But we are given that n of x cross y equals 6. We can conclude that n of y equals 3, because 2 times 3 gives 6. So the number of elements of the set Y is 3 elements. Now the number of y2 will be 3 squared, which is 9. Okay. Now we are going to talk about the different forms of the Cartesian product, and I need all of your attention. The Cartesian product has 3 forms. One of them is in the form of a set of the ordered pairs, and I think we are familiar with this because we are using it from the beginning. The second form is an arrow diagram. The third form is a Cartesian diagram. Now we are supposed to know about arrow diagram and Cartesian diagram. Arrow diagram, each ordered pair is represented with an arrow. In arrow diagram, each ordered pair is represented with an arrow. This arrow oriented from its first projection, from the first projection of this ordered pair to the second projection. Pretty simple. Okay, that's about the arrow diagram. Now, what about the Cartesian diagram? In the Cartesian diagram, each ordered pair is represented with a point. This point is opposite to the first projection on the horizontal axis and opposite to the second projection on the vertical axis. Each ordered pair is represented with a point. That point is opposite to the first projection on the horizontal axis and opposite to the second projection on the vertical axis. Let's see some examples. If x is the set of 1 and 5, y is the set of 2 and 8, then x cross y is the set of 1, 2, 1, 8, 5, 2, 5, 8, and this is the first form of the Cartesian product, which is a set of ordered pairs. Now let's see the second form, which is, do you remember? Can you recall it? Yes, arrow diagram. How will be the arrow diagram of this Cartesian product? Here is the set x, and here is the set y, and as we said before, each ordered pair will be represented with an arrow oriented from the first projection to the second projection. So this arrow represents the first ordered pair in the set, whose first projection is 1 and second projection is 2. And this arrow represents the second ordered pair, whose first projection is 1 and second projection is 8. This arrow represents the ordered pair 5, 2, and this arrow represents the ordered pair 5, 8. This is about the arrow diagram. Let's see about the Cartesian diagram. In the Cartesian diagram, here is the first set, which is set x. Here is the second set, set y. Each ordered pair is to be represented with a point opposite to the first projection on the horizontal and the second projection on the vertical. This point is opposite to 1, which is its first projection from the horizontal, and opposite to 2, which is its second projection on the vertical. Okay? This point represents the ordered pair 1 and 8. This point represents the ordered pair 5, 2. This point represents the ordered pair 5, 8. That's about the 3 forms of the Cartesian product, which are set of ordered pairs, arrow diagram, and Cartesian diagram. Let's see another example. If x is a set of 3 and 5, then x2 equals, I think you are familiar with finding the Cartesian product on a set. So x2 is the set of 3, 3, 3, 5, 5,3 and 5,5, and this is the first form of the Cartesian product x2. What about the second form, which is arrow diagram? The set x, its elements, the set x, its elements. Each ordered pair is to be represented with an arrow oriented from the first projection to the second projection. There is another way for the arrow diagram. Here is the set x, and these are its elements. Each ordered pair is to be represented with an arrow from the first projection to the second projection. So this ordered pair 3, 3, how will it be represented? By this arrow. This arrow is oriented from 3 to itself. Okay, what about the second ordered pair 3, 5 will be represented with this arrow, which is oriented from 3 to 5, 5, 5 and 5, 3. Now the Cartesian diagram, x on the horizontal, x on the vertical, and each ordered pair is to be represented with a point opposite to its first projection on the horizontal and its second projection on the vertical. Answer the following. Complete. If x cross y is a set of 2, 6, 2, 9, 3, 6, 3, 9, 5, 6, and 5, 9, then x equals, you are required to find the set of x. Okay, pretty simple. X is the set of the first projections. Okay, first projections are 2, 3 and 5. So x is the set of 2, 3 and 5. Ignore this round brackets, it's a printing mistake. Okay, find set of y. Y is the set of the second projections, which are 6 and 9. So y is the set of 6 and 9. X cross y, pretty simple. He gives us x cross y, which is the set of 1, 1, 1, 3 and 1, 5. Then he wants us to find the set x. X is the set of the first two projections, which is 1. So x is the set of 1. Number 2, y. Y is the set of the second projections, which are 1, 3 and 5. So y is the set of 1, 3 and 5. Number 3, y cross x. It's even easier than 1 and 2, because we are going to shift the projections. Okay, the first will be the second and the second will be the first. That gives us the ordered pairs 1, 1, 3, 1, 5, 1. Okay, number 4, y2, y cross itself, will give us 1, 1, 1, 3, 1, 5. That's when 1 is the first projection. 3, 1, 3, 3, 3, 5, and that's when 3 is the first projection. And finally 5, 1, 5, 3 and 5, 5, and that's when 5 is the first projection. Choose the correct answer. If the ordered pair 3, 5 belongs to the Cartesian product set of 3 and 6 cross set of x and 8, then x equals, you can easily note that x is in the second set, which is the set of the second projection. So x is supposed to be a second projection. The second projection in our ordered pair is 5. Okay, That means that x equals 5. So the right answer is C. Pretty simple. If set of 2 cross set of x and y equals set of 2, 4 and 2, 3, then x minus y equals. The set of x and y is the set of the second projections. That means that the second set is the set of 4 and 3. Okay? But which of them is x and which of them is y? We cannot tell. X can be 4 or 3 and y can be 4 or 3. So when you find the difference x minus y, if x is 4 and y is 3, it will give 1. And if x is 3 and y is 4, it will give negative 1. So the right answer will be exactly C, positive or negative 1. It can be 1, and that's when x is 4 and y is 3. And it can be negative 1, and that's when x is 3 and y is 4. Okay? If x is the set of 2, again ignore this mistake. It's supposed to be curly bracket. X is the set of 2, y is the set of 3, then x cross y equals 6, set of 6, order pair 2, 3, or the set of order pair 2, 3, exactly it's number D. That's an arrow diagram. Okay, what's required? It says the opposite diagram represents. The opposite diagram represents x difference y cross y difference x, or x intersection y cross x, or x cross x intersection y, or x cross y. I want you to remember that the Cartesian production doesn't leave any element of any set without using it as a first projection or as a second projection. But here you can note that 2 isn't a first projection, 4 isn't a first projection, and you can note that 2 isn't a second projection, 4 isn't a second projection. Okay, so it's not x cross y. But what are these elements which are a first projection? 1 and 3. These are the elements which belong to x and doesn't belong to y, which is exactly x difference y. And now, what are these elements 6 and 8, which are the second projection? These are the elements which belong to y and don't belong to x. Yes, which is y difference x. So the right answer is x difference y cross y difference x. Let's see another exercise. Let me tell you that I came up with these two exercises. I don't think you'll find them in any other resource. If y is a subset of x, then the following diagram may represent x difference y cross y, x difference y cross y, of course it's a mistake, x intersection y cross x, x cross x intersection y. Okay, Number B is supposed to be cross x. Again, the choices are x difference y cross y, x difference y cross x, x intersection y cross x, x cross x intersection y. What do you think is the right answer? Okay, you will find that only two elements which are a first projection, 1 and 2, okay, and only three elements which are a second projection, 3, 5 and 4. Okay, so the right answer may be x difference y cross y, right? Of course, that is the right answer. Why? Because x difference y are the elements who belong to x and don't belong to y. Okay, don't forget that y is a subset of x. So 1 and 2 are the elements who belong to x but don't belong to y. What about 3, 5 and 4? 3, 5 and 4 are not all the elements in x. They are subset of x. And it's obvious that they are the elements of y, because 1 and 2 don't belong to y. So 3, 4 and 5 are the elements of y. So the right answer is x difference y cross y. Why it isn't x difference y cross x? Because if it's the right answer, the arrows were supposed to be oriented to each element in x. Okay, why it isn't C? Why it isn't cross x? For the same reason, because if 1 and 2 are the intersection between x and 1, so these arrows are supposed to be oriented to each element in x, which is not happening. Number D, it's obvious it's not the right answer, because in this case the arrows are supposed to be oriented from each element in x. In another meaning, in another words, each element in x is supposed to be a first projection. I hope this video is useful for you. Thank you, and Assalamu alaikum wa rahmatullahi wa barakatuh.